In astronomy, it is common to deal with grayscale images, where each pixel of the image corresponds to a measured quantity, like the flux recorded by a camera. To visualize an image, we can use the imshow function of Matplotlib. For this example, we will use the AstroPy module's fits and download file to download the data and open it. The fits format is one of the most commonly used formats in astronomy. The fits module has a number of functions to load the data. In the present case, we will only load the data itself, omitting the metadata. Once loaded, we can print a bit of information about the data, like the minimum and maximum values. We will plot this data using the imshow function and also show a color bar to get information about the values associated to the colors. After running these lines, we get the following result of the Horsehead Nebulae. The default color may vary depending on the Matplotlib version you are using. Say we want to highlight the structure of the Horsehead Nebulae in this image. To do so, we want to hide all values smaller than 5,000 and greater than 9,000. This can be done using the Vmin and Vmax parameters, which will constrain the luminance data. This will give us the following result. In the next exercise, we want to set the axis ticks and labels with the fits information with world coordinate system. This can be done by utilizing the WCS subpackage of AstroPy. What needs to be done here is to pass the header information taken from the fits file to the WCS constructor, and then passing the result to Matplotlib to specify the projection. This provides a way to set the ticks values using the inherent information of the data. Here's the result. As you can see, the results are now in degrees and arc minutes. Next up, set a discrete color bar. For example, set the values between 0 and 5,000 to blue, from 5,000 to 10,000 in purple, and so on. To start, we can reuse the code that we already defined, like using the WCS information. Then, we pick a color map, here the yellow, green, and blue color map from Piplet. Now, we need to quantize our value range into a number of bins. We will set the number of bins to be 10. For any quantization, we need a minimum and maximum, which we will set using the data's limits. Then, we can set our bounds using the arange function from NumPy. It would also be possible to set this list manually. Here, we will set a list ranging from min to max plus 1, where each step is defined as max minus min over the number of bins. This is a linear quantization step function. We will use these newly defined bounds along with the boundary norm function from the Matplotlib color subpackage. This will generate a color map index based on discrete intervals, which is exactly what we want. We can now plot the data while specifying the extra parameters CMap for the color map and norm, our color map index. Finally, we will also pass extra parameters to the color bar to specify the ticks values and boundaries. And here is the result with our discrete color bar.